In the previous video, we talked about base units, and one of the base units that I mentioned is the mole. Now, the mole is used to calculate substances that are extremely small, like the atom and molecules and ions. The mole is a number. Like when I say dozen, you automatically think of 12. When I say pair, you think of 2. When I say baker's dozen, you think of 13. The mole is just that. It's a number. The number is 6.02 times 10 to the 23 atoms. Now think of that number real quick. Times 10 to the 23. Is that a very large number or a very small number? It's a large number. It's 10 to the 23rd power. So before I really talk about it, I want you to imagine, think about an atom. Can you see an atom? You can't, right? Not with your naked eye. What if I were to give you 6.02 times 10 to the 23 atoms of a substance? Could you see it now? It's probably hard to imagine what that would look like, right? So let's take aluminum for example. If I gave you an atom of aluminum, would you be able to see it? No, you wouldn't. If I gave you 6.02 times 10 to the 23 atoms of aluminum, you could see it. And it looks something like this. This is probably a blown up picture, but it would be a ball of aluminum. It makes it so that scientists are able to work with the substance. We're able to count the atoms, and this is what a mole is. So 6.02 times 10 to the 23 atoms of aluminum is equal to 1 mole of aluminum. Now to explain how big a mole is, I'm going to show you just a clip of this video.
Exchange the water particles for donuts. If you had a mole of donuts, they would cover the entire Earth to a depth of 8 kilometers, which is about 5 miles. You'd really need a lot of coffee for that. If you had a mole of basketballs, you could create a new planet the size of the Earth. If you received a mole of pennies on the day you were born and spent $1 million a second until the day you died at the age of 100, you would still have more than 99.99% of your money in the bank.
Now, hopefully that video gave you an idea of how big the actual number is. So in chemistry, the mole is a unit of measurement. Again, we can't see one atom, right? But when we say 1 mole, we know that we are talking about 6.02 times 10 to the 23 atoms. And this makes it so that it's easy to convert and count atoms, molecules, ions, particles, substances that are extremely small, things that we cannot see with our naked eye. So 1 mole is equal to 6.02 times 10 to the 23 particles. Now that word particles can also mean different things. So it could be 1 mole is equal to 6.02 times 10 to 23 atoms. 1 mole is equal to 6.02 times 10 to 23 molecules. 1 mole is equal to 6.02 times 10 to 23 ions. And 1 mole is equal to 6.02 times 10 to 23 formula units. The whole point is that all of these particles are extremely small. Particles, atoms, molecules, ions, formula units. This number is called Avogadro's number. So when you think of 1 mole of a substance, think of Avogadro's number, 6.02 times 10 to the 23. So now let's use dimensional analysis to help us convert moles to particles and vice versa, particles to moles. How many moles are in 1.20 times 10 to the 25 atoms of phosphorus? So we want to set up our fence, and we begin with the top left corner with 1.20 times 10 to the 25 atoms of phosphorus. Now units are important, so please get into the habit of writing all the units. So here we have atoms and the substance, phosphorus, P. And remember what we do next in our fence. We bring down the unit and unit only atoms of P, atoms of phosphorus. Now remember what the second half of this fence represents. It represents a conversion factor or a relationship. So what is the conversion factor that we're talking about? Well, throughout the video, there's really only one conversion factor that we'll be using. It is 1 mole is equal to Avogadro's number. And remember that Avogadro's number represents different units. So we have particles, atoms, molecules, ions. So here we'll put atoms on top, okay, instead of particles. So remember that we can write this conversion factor as a ratio. And what is one way to show a ratio? It is a fraction form. So we can write it as 1 mole over 6.02 times 10 to the 23 atoms. Or we can write this ratio as 6.02 times 10 to the 23 atoms per 1 mole. Now, which one are we going to use? The one on the left or the one on the right? Well, because it says atoms on the bottom of the fence, we do want to choose the one where it has atoms on the bottom of the ratio. So we're going to use this one and plug it into our conversion factor fence. So atoms on the bottom, mole on the top, and go ahead and match the numbers. So 1 mole is written on top, so we write 1 mole on top and 6.02 times 10 to the 23 atoms on the bottom. And here we see that our like unit, atoms, cancels out. And what you do in your calculator is you want to make sure, remember, because we are multiplying across and dividing by the bottom, in your calculator, make sure that you are using the parentheses. So 1.20 times 10 to the 25 divided by parentheses 6.02 times 10 to the 23. The parentheses really do make a difference, especially if you're dividing by a number that's in scientific notation. So please don't forget those parentheses when you see scientific notation and you're doing some math with that. So when you do that, you do get an answer of 19.9 moles of phosphorus. Number 2. How many moles are in 3.87 times 10 to the 21 formula units of AlF3? So formula unit is also another word for particle. Okay, so how do we begin? We begin with the number written in the top left corner. And for formula units, we do want to go ahead and write everything out. And then we draw the fence. We bring down the units, formula units, and what are we going to put on top? Right, mole. This is the only conversion factor that we're looking at today. So where we see mole, we write 1. Where we see formula unit, we write 6.02 times 10 to the 23. Our like units will cancel out. Go ahead and put this into your calculator. You should get an answer of 6.43 times 10 to the negative 3 moles of AlF3. How many molecules of Cl2 are equivalent to 4.2 moles of chlorine? So this time, we begin with moles. And again, we bring down the like unit. Now, what's going to be on the opposite of moles? What does it want? It wants molecules. So mole and molecule will go on top. So how many moles? 1 mole. How many molecules? 1 mole is equal to 6.02 times 10 to the 23 molecules. Moles cancels out. And then you put that into your calculator. You multiply, right? 4.2 times 6.02 times 10 to 23 divided by 1. And you get an answer of 2.5 times 10 to the 24 molecules of chlorine. If you're wondering why I'm going from moles, M-O-L-E-S, to M-O-L, the abbreviation for M-O-L-E-S, moles, is M-O-L. Why we drop off one letter just to write that abbreviation, I'm not quite sure, but MOL is the abbreviation for moles. It is not the abbreviation for molecules. Okay, how many sodium ions are equivalent to 2 moles of sodium ions? So we have ions and moles. And remember that ion is also another word for particles there. So 2 moles. We're going to go ahead and bring down the word mole. And on top we'll write ion. And how many moles is equal to how many ions? 1 mole is equal to 6.02 times 10 to the 23 ions. So pretty much whenever you see the word mole throughout today's practice problems, you write 1 next to it, and all the other words you write 6.02 times 10 to the 23. Moles cancels out. You multiply 2 times 6.02 times 10 to the 23 is equal to 1.204 times 10 to the 24 ions. Go ahead and work on these practice problems. We will go over these problems in class. Please make sure that you are practicing the setup on your paper as well. Think about what you are starting with, what you are given, and what the problem is asking you to find. So pause the video here, show the setup, put in your calculator, figure out the answer, play the video when you're done to see the answers.